We're all pretty used to AI on our phones and in our search results. But now it's starting to show up in a place that's a lot more personal, our hospitals. It's helping doctors spot diseases earlier than ever before. But with that incredible power comes a really big question. How do we make sure these so-called robot doctors are actually safe and effective for every single one of us?
The best way to think about it is like a job interview. Seriously, before any AI can start helping your doctor make decisions, it has to prove it's actually qualified for the job. So who's the hiring manager in this scenario?
Yep, you guessed it, the U.S. Food and Drug Administration. They're the gatekeepers for these new digital health tools, and they've just put out their new playbook, a draft guidance, really, that outlines exactly what they're looking for in any AI that wants a job in healthcare.
So in this explainer, we're going to walk through that entire FDI interview process. We'll look at what an AI medical device even is, how it's built, how it gets tested, what happens after it's on the job, and finally, how the FDA is trying to make these super complex tools a little less mysterious for everyone. Okay, let's dive right in. First things first, what are we even talking about when we say an AI-enabled device? This isn't just some fitness app on your phone. It's a whole different ballgame.
The FDA has a pretty technical term for it, of course, but what it really boils down to is any piece of software that has a real medical purpose. It uses an AI model to make a prediction, like spotting something weird on an X-ray or detecting an irregular heartbeat. This isn't just about wellness, it's a regulated medical tool that can have a huge impact on your health.
So how do you even build one of these things? Well, before an AI can even think about applying for a job in a hospital, it has to go to school. And for an AI, that education comes from just one thing: data. Lots and lots of data.
This is like the golden rule of machine learning. You've probably heard the saying, garbage in, garbage out. Well, it's never been more true. The AI learns patterns from whatever data you show it. If that data is fantastic and diverse, you have a shot at a great tool. If the data is biased or incomplete, well, you can imagine the problems. And that, right there, is the million-dollar question. What if the school this AI went to only taught it about one type of patient? What are the real-world consequences of that?
The risks here are just enormous. An AI trained mostly on data from, say, white men might be way less accurate for women or people of color. That could lead to serious misdiagnoses and make existing health inequalities even worse. This is exactly why the FDA is so laser-focused on the data that goes into these models.
And just to give you a sense of the scale we're talking about, let's use an example from the FDA's own document. They describe a hypothetical AI built to screen for something they call Disease X. Well, that AI was trained on the heart scans, ECGs, of 30,000 different patients. That's a huge amount of data just for its basic education.
And this is where the FDA's demand for transparency really shines. They want companies to provide a detailed demographic breakdown, just like this one. They're essentially saying, show us your work. Who did this model learn from? And most importantly, does that group of people actually reflect the diverse patients who will be counting on this tool in the real world? Okay, so the AI has been educated on a good, diverse data set. Now comes the big test. Can it actually do the job it was designed for? And, even more critically, can it do it safely?
This little phrase right here. This is the heart and soul of the FDA's mission. It's the high bar that every single medical device, from a simple thermometer to a complex surgical robot, has to clear. For an AI, this means proving its predictions are accurate, helpful, and above all, safe.
The FDA wants to see the cold, hard numbers. In that Disease X example, the company had to show how well its AI performed on a totally new set of data it had never seen before. You see two key metrics here. Sensitivity, that's how good it is at catching the disease when it's there, was 87%. And specificity, how good it is at correctly giving the all clear, was 83%. These are the kinds of hard stats that prove the AI can actually walk the walk.
But it's not just about getting the right answer. Companies have to spend a lot of time thinking about what could go wrong. What if the AI gets it wrong? What if a doctor misreads the result? They have to identify all these potential problems, build in safeguards, test them, and document every single step of the way.
All right, so our AI has passed its exams, it aced the interview, and it got the job. But here's the thing about working in medicine. The interview is never really over. The FDA is very clear that making sure this tool is safe is a job that continues every single day it's being used.
Now, why is that? Because the real world is messy and it's always changing.
The kinds of patients a hospital sees can change, diseases themselves can evolve, and even a brand new piece of scanning equipment can change the data the AI is seeing. There's actually a name for this. It's called data drift, and it's a huge deal. And AI's performance can slowly get worse over time if the world changes around it, which is why that constant monitoring is an absolute must.
And in our totally connected world, there's another huge ongoing risk: cybersecurity. Just think, if a hacker could mess with the AI model or the patient data it relies on, the results could be catastrophic. So protecting these devices from cyber threats isn't just some IT problem. The FDA sees it as a fundamental part of patient safety. Full stop.
So the AI is well-trained, it's passed its tests, and it's being monitored on the job. But there's one final, massive hurdle to clear: trust. How can a doctor actually trust a recommendation that comes from what often feels like a mysterious black box?
We've all heard this term, right? These complex algorithms can be incredibly powerful, but sometimes their inner workings are so complicated that even the people who designed them can't fully explain how they reached a specific conclusion. And that lack of transparency can be a major roadblock in medicine.
I mean, put yourself in a doctor's shoes. How can you confidently act on an AI's advice if you don't really understand its strengths, its weaknesses, or where its blind spots might be? This is the final and maybe the most important part of the AI's job interview.
And the FDA has a really elegant solution for this. It's called the model card. Honestly, the best way to think about it is like the nutrition label you see on the back of a box of cereal. It's a simple, clear summary of everything you need to know to use the AI's output responsibly.
This single document lays out all the most critical information. What's this tool actually supposed to be used for? How well did it do in testing? What are its limitations? Where might it get things wrong? What kind of data was it trained on? The model card puts all of these essential facts right at a doctor's fingertips, helping them use the tool safely and effectively.
So there you have it. From diverse data to tough tests and finally to transparent labeling, the FDA has laid out a pretty solid plan for the AI of today. But this technology is moving at lightning speed, and it leaves us with a big question. As these models get even more powerful, even more autonomous, what will the next chapter of the rulebook need to look like?